Let's go back to, oh, there she is. Okay, let's go back to an earlier lesson here. And I think the page number for the math, yeah, well, there's some stuff we haven't finished here. There's actually quite a few things. The page number will be, wow, there's a lot of stuff we didn't finish on the last time. Okay, so we are now on page number 112 and talk about math, okay? And then I'll collect the homework a little bit later, but we'll be on 112. Make sure you put your stuff in order, otherwise you're going to be like in sorting a lot of stuff. Let's talk a little bit about figures. And the thing that's kind of interesting here, everyone should be on 112, and it has these figures: triangle, rectangle, pentagon, hexagon. Whenever you add another side to a figure, you're adding 180 degrees. So if you look at the first one, which is a triangle right there, let's just fill in the numbers here. It's 180 for that one. How much is a rectangle? 360. How much is a pentagon?
No.
Adding on 180 to the 360.
540.
540. And then a hexagon. None of you guys are skateboarders or snowboarders, right?
No.
Because if you ever watch the X Games, you always hear the commentator when someone's doing it, they're like, oh my goodness, he did a 720 backward Japan grab, goofy. And you're like, what? What did he say there? I don't know what the heck he said. I don't know if you guys ever watched the X Games or the Winter Olympics and they do the snowboard competitions and they say all these things, they're describing whatever the person's doing, like, dude, he did the 1080 McTwist Japan grab. And you're like, huh? Okay. All right. The point behind this is, what if I gave you a figure that was 19-sided? Would you sit there and add 180, add 180, add 180, add 180? Because this was pretty easy. These figures is 3-sided all the way to 6-sided, right? But if it was a 19-sided figure, I'm going to give you a formula here. So
should that be written on B or just write?
I would write it for A because we're still talking about that. B, we're going to talk about something else. But what you have here, degrees in a figure is equal to degrees in a figure is equal to sides minus 2 times 180. So if you did have a 19-sided figure, you would multiply 17 times 180, and that would be 17 times 180. If the answer is 3060. Yes.
Sorry, what do you mean by degrees?
Inside the figure, so like.
Oh, degrees. I just answered it. Sorry.
Degrees inside the figure.
Right.
If it was a 19-sided, the answer is 3060 degrees inside of the figure.
Right.
That's what what we're saying here. Okay. So this little formula will help you if you ever run into something. They rarely give you a 19-sided figure, but it's something good to know. Okay. Let's go with the next part, which is part B. It says a diagonal divides a square into 2 isosceles right triangles. Isosceles right triangles. So what's interesting here is question number 7 right below actually has a square in it and a figure. I'm just going to draw this. It's kind of like this. So for part B, a diagonal is a line that cuts from end to end. And it cuts the square into 2 isosceles right triangles. So it's going to look like this. Okay. How do I know it's 45 and 45? Does anybody? Hey, Grace? Yeah, since you're splitting that 90, you know it's going to be 45 and 45. Jasmine, you want to read question 7 right below it?
Two squares to the second. The area of the shaded region is 144 square inches. The diagonal of the smallest square inch measures 16 inches. What is the area in square inches of the largest square?
Okay, so we've cut this in half by doing that. Let's label the figure. So the shaded region is 144, so I'll just draw an arrow here. And then they also tell us that the diagonal equals 16, right? So we have that information there, right? So to find the area of the larger square, what do we need to find? Nick? Right, so here's our formula here. Let's connect to darken. Would everybody agree, area of the larger square is equal to the area of the smaller square plus the shaded region?
Yeah.
Right? If you look at that figure, the shaded region is the frame. That's already blacked in, right? It's shaded, right? So we already know the number for that. That's 144. We have this already. Since we're finding the area of the large, why don't we find the area of the small?
Yes.
So we have the diagonal. Can we find the length and width? Because area of a square is length and width, right? So we need that. Can we find that? Okay. This is relative to what we learned earlier this week.
I know. You have to use the concept of 45, 45, 90 triangles.
Right.
So the base here is 16. So
that's not the base.
Or no, hypotenuse. The hypotenuse.
That is the hypotenuse.
Yeah.
Right.
So there's x. So there's x.
Okay.
And then x root 2, right?
That's right.
So x root 2 is equal to 16. 16 divided by root 2 is.
Right. So he is, okay, I want everyone to write this down. I don't want you guys to go, I didn't really get this, so I'm just going to stare. I want people to write this down because this is the secret to finding the other two legs. Remember on Monday I said, it's easy to do the Pythagorean if you have a leg and a leg, or if you have a leg and a hypotenuse. But what if they only give you one? This is the way you do it.
And it'll always be something like that.
If it is a 45, 45, 90, or if it is a 30, 60, 90. So back to this, because Shakaran was already plowing way ahead already, and I didn't want to go further without everyone following this. He knows that x root 2 equals 16. Let's set up the equation here. Right? Because this is called x and this is x also. So remember how I drew this. Remember I said the 45 degrees corresponds with this leg. This 45 corresponds with this. The 90 corresponds with the hypotenuse, right? So we already know the hypotenuse. We're looking for the two legs here. So what's it going to be? You're on a roll. I kind of slowed you down, but what would you do next?
Well, you try to find x, so you divide by root 2.
That's right. Okay, go for it.
16 root over root 2 can't have a rational. You have to rationalize it. So root 2 over root 2 times 16 over root 2. 16 root 2 over 2. And that's your x. So those are.
We need to reduce this, right?
Oh, I'm sorry. Then that would be an 8 root 2.
So this helps us a lot because by doing this now, you have this leg and this leg. Since we have both of these now, let's just multiply them because that's length times width.
Okay.
The
So
square,
those are the sides, right?
the sides of the, we don't need to do it just as a triangle. We want to treat it as this is equal to length, this is equal to width, right? Question there, Nick?
So it would be 64 root 2.
It would be 64 times root 4. So let's do this.
64 root 4.
Right. So you have 64 times root 4, and root 4 equals 2, right?
Oh, I thought the numbers would not add up.
128.
That's right. 128 is the answer to just the the area of the small. Now we have area of the small, and we already have the area of the shaded. So let's add them up. So you have the shaded, which is 144. You have the area of the small, right? So when you add these up, what do they add up to?
To the area.
Yes.
172.
172? 272, Grace. Thank you. So 272 is right. So 272 is correct there. So I know this felt like, oh my gosh, that's a lot of info. I'm going to scoot this thing out because I kind of filmed this for Yanni. But I don't know if you can see that. But 272 is the answer on that one. Okay. So because we added the area of this, the white small square, plus the shaded, which was given to us, and we got the total, which is the area of the large. That's 272. Okay. I know this was a little bit tricky. That's kind of why I wanted to walk through it together on that one. Any questions on that? Because what we're doing is we're just applying what we talked about the other day about triangles. Okay. Below this, so the answer here was 272. It's a bubble in question. For part C here, they're just saying when they call a hexagon a regular hexagon, what that means is all of the sides are equal to each other, and inside of it are 6 equilateral triangles. Everyone knows what equilateral triangle is.
Mm-hmm.
That means equal sides and equal angles inside of them. So that's why that drawing looks the way it does. The bottom triangle shows you it's 60, 60, and 60. The other thing that they note here is the interior angles are all 120 if you count. See that one on the edge? When I draw this thing here, this is my ugly. These are all 120s. That's what they're saying there. Okay. So just keep in mind what regular hexagon is, and it's right there. The drawing's better than my drawing. Let's try this. We'll do number 8 together, and number 9, I will let you guys do it. But let me have Nick read 8 for us.
The figure above, the hexagon with center P has 6 sides, each of length 6, and 6 angles that measure 120 degrees. What is the length of line JK?
All right, any ideas here? Shavarin?
Well, we could break the hexagon into equilateral triangles.
That's a good idea, because we just talked about this. This is a regular hexagon right here. Since they told us this is 120, that tells us, this is probably going to be a regular hexagon. So just to make it very easy, this is all 6s here, and let's just break this. Okay, let's just start there. I don't want to draw all the lines. I mean, I could, sure, but it's going to confuse you, and I don't want to put too much stuff in there. We know that this is a right angle at the bottom here, okay? And this is a right angle up here. Okay, what kind of information did they give us that helps us here? Nick?
The length of them are 6.
Yeah, all of these are 6. So this length from here to here is also 6. What would you do with this? This is 6 down here, 6 up here.
Well, you know, like the base of the triangles.
So this is 3 and 3 here. Okay. What else do we know?
Hypotenuse.
We do know the hypotenuse, right?
So
These are
Pythagorean theorem.
Because it's equilateral, all the sides are equal, right? The angles are equal. Do we know the angles?
120.
That's if you do the whole thing like this. But from this black line to the blue line, what is this?
60.
It is 60, right? So I'm going to write this in here. All right, if that's true, then what is this angle on this side and this angle on this side? Up here, here, and
That's 30 and 30.
30 and 30, okay?
Mm.
Good.
Mm.
I'm not hearing too much from the
Oh.
girls right now, but do you guys see where we got all this information from? Because just like a minute ago, we talked about a regular hexagon. Inside of it is 6 equilateral triangles. So all we're doing is we're assuming this information here, and this line that's drawn from P to K just divided this into 2 triangles. That's why it's 30, 30. Because up at the top, it's still 60. This is a 60, 60, and 60. This was 6, 6, and 6. You just split this into 3, 3 and 3, right? So there was nothing new, no real calculation going on. It's just assuming information here. That's all we're doing. Are we able to find this line from P to K with this information?
Yeah.
Okay. There are a couple ways of doing it. What would you do then, Nick?
Like, well, since we know that, like, if we know the size of the right triangle, we could do the Pythagorean theorem.
You could do the Pythagorean. So here, I'm going to draw this a little bigger.
I did already, and it would equal x squared equals 27. So
You could do Pythagorean here. What else could you do? Because we know this is 60, and we know this is 30.
30, 60, 90 triangle.
30, 60, 90. So this is the fast way. This is at the beginning of the real test on the SAT. You flip back there, you're like, oh, they gave me this 30, 60, 90. They gave me the proportions. You don't have to memorize it, but you do need to know when you can use it. Because a lot of students never go back to that and go, oh yeah, they got the formulas right here. I can use this, right? If this is not part of your active memory, you won't even turn the page, right? So that's what I'm trying to do is, instead of defaulting to Pythagorean, I'm trying to train you guys to think like the test makers. Yes, Shankar.
So are all of these problems, like math problems specifically, have this sort of like mechanized process of like there is a
They're
way?
very likely to. In fact, what I will tell you, that's a great question, is when you guys get right triangles, most of the time you'll be able to use the Pythagorean. You'll be able to use either 30, 60, 90 or 45, 45, 90, or the Pythagorean triplets. Remember 3, 4, 5, 5, 12, 13.
Yes.
Once in a while, they'll give you weird ones where you can't use it. But for the most part, all these things that we've talked about, they come to life on the test. Because, and I'll tell you why they give you these, because you're starting to go, whoa, I'm seeing a system here.
Right.
They're just doing this same stuff over and over. Not everyone has a calculator. The SAT doesn't say in order to take the test, you must have a calculator. So to accommodate students who do not have calculators, they make them so that, hey, I know the trend. I could do this whole thing without a calculator. And I've had students who, on the morning of their test day, they're like rushing to get to the test, and they forgot their calculators, but they still got like really high scores because they knew what they were doing on. So I know that seems very nerve-wracking, like, oh my gosh. But no, you can do it without the calculator. I like that. But you're seeing it right here. I'm just going to label this. Which one is 30?
The top.
Yeah, so what's the value?
Oh,
3.
It's 3, right, Jasmine? Okay, and then what does the 6 represent? 90.
oh.
So remember, this was X, this is 2X.
They cross, yeah.
So you need to find this one. So what's it going to be? Because this is, you guys remember the proportion here? X, 2X, what's another one?
X root 3.
X root 3. That's it.
Hey man.
So we know what X is already, so you just apply it. You guys got it. Okay, good. I heard one of the girls say it. So
yes.
we have 3 root 3. I'm going to just draw it over here.
So the base is 3 root 3.
Do we need to do much more calculating now?
No.
We have P to K. We can pretty much assume J to P, right? This is J to P. J to P is going to be how much?
3 root 3 times 2.
Yep. So this is 3 root 3. So the whole thing from J to K equals J to K equals how much?
I don't know how to add them.
Okay.
Is it 6 square root of 6?
It's just going to be 6 square root of 3. So that would be your answer.
Okay. There's a y in the last problem.
And that would be it, 6 root 3. They didn't even have 6 root 6 there, so you would probably go, I think it's the 6 root 3. So that would be your answer. So this is where all of these things come into play. That's the reason why we're learning these little definitions. And what I'm really trying to get you guys to actively think of the 30, 60, 90 relationship. Okay. Let's everyone do number 9. I think you can do it without me, and we'll come up with our answers. So go ahead and do that for a minute. So, quick question. What was the first thing that we thought of doing here? Nick?
Counting all the sides.
Right. How many sides are there?
5.
So 5 sides. And then how does that help you?
Because earlier we talked about the degrees, the total amount of degrees in the figure
Right.
is 5 sides minus 2 times 180.
Right. And you got how many degrees on that?
I got the math wrong, but 40. Yeah.
It's 540. So the total has to be 540, right? For this entire figure. Does this help? The girls were kind of looking, but I could tell they weren't really done yet. Did that help you guys to figure out the rest of this?
Yeah, but I just didn't finish it. The answer of
Okay.
like the other sides. Wait, you do like 540 minus 325?
Yeah, so you added these 3 up, right?
Yeah.
325, that's right. And then what do we get for this one?
215.
It should be 215. Yeah, that's right. 215. That's what this equals right there. That was correct. Everyone see it?
Yeah, I thought they wanted us to calculate A and B first, and I was like, whoa.
So
That's what I was,
this is similar. Remember we had a triangle the other day, and it was saying, what is the value of A plus C plus D plus E?
Yeah.
And I think when you guys were doing it, you guys were probably looking for the individual values of A, individual value of C, D, and E. This is the same trick again. They're not asking you to find the individual values of A and B, just the total. And that's all you had to do right here.
Wow.
Same trick, okay? Yeah, but now you guys are getting familiar with it, and it's not feeling so different, right?
Right.
So you guys are starting to see that. Okay, you guys ready to turn the page here? This makes sense, 215. All right, so let's go to the next part. We're talking about circles here, and they do give us these formulas in the front. But I do want to say this, know which one is which. I know oftentimes they look similar to each other. Circumference is 2 pi r, area is pi r squared. But we should know, what is the definition of area? Nick?
Amount within.
Within. Circumference?
Around.
Around.
Perimeter.
Shankar says, yeah, around. So it's the perimeter of it. Okay.
Yeah.
All right. I don't even know who I had read the last couple of problems here, but Grace, did I have you read one? You want to? Okay, go ahead and do number 10. Read that for us. Okay. I just drew what they gave us here. Whenever they give you a figure, let's label this, right? The first thing they tell us is what? Area equals 36, right? 36 pi, that's what we have. If they give us 36 pi, how does that help us with this figure? Shankaran, you're here.
Then you
How does, just the 36.
36 pi.
Yeah, how does that help us, just that part?
Well, then you can just replace the area with the equation pi r squared is equal to 36 pi. And then that, if I can go on.
Yeah, keep going. This is good. I like it. Keep going.
That means then the pi is already there, right? So it's just, I mean, you could just divide them by, it's r squared equals 36, so r is equal to 6.
Good, that's what I was hoping to hear. So you found the value of r.
You know, and
R is 6. So 6 and 6, right? So we have the radius.
Yes.
If this helps us, now, the second part of this question after the if phrase that they have here follows the comma. It says, then, what is the circumference of a circle whose radius is 2x? Nick?
Is that talking about x being the radius that was already given? Or
X is a value, and I'm going to ask you guys this question. How many circles are they talking about here in this question?
2.
Correct. A lot of people go, well, they only drew one, so that's all I'm thinking about. But they just wanted to see if you can think of another circle, and that's what they're doing, because the second one has a radius which is larger than the diameter of the first one. So this is pretty huge, right? I purposely drew it larger because if x value here is 12, what's the radius on that one?
12.
No.
Grace? Yeah, 24. Yeah, so Grace is telling us this is 2 times 12. It's I mean, if I was to really draw it, it'd be a lot bigger, but I don't want to, use up the entire board just to draw. But now the question is saying, what is the circumference of the second circle? It doesn't say what is the circumference of the second circle, but it says a circle whose radius is 2x. So what's our answer for this one?
48.
Right, so this radius equals 2 pi r from 2 pi 24. Shankaran gave us the answer, but I just wanted to write everything there.
Yeah.
48 pi is your answer for this one, okay? So it's the second circle that they're asking about. That makes sense to everyone, right?
Yeah.
This is the kind of tricks they throw at us on the SAT, because these formulas are not hard, but they'll twist the question, and some people will go, wait, are you talking about one circle or two, right? Okay. Another important thing here is dealing with the arc and the sector of a circle.
Oh, yeah.
I don't like the way this formula is kind of written there, but what I'll tell you is they're talking about proportionality here. And let me just erase this one here. So this circle looks like this. Okay, that's what they have. Well, they didn't really write 90. I'm just going to write x degrees. Okay. What they're saying is this is the central angle, x. Okay. It doesn't have to be 90. It could be whatever. I don't know what it is. And if you have the central angle, x, it is in proportion to the arc divided by the circumference. I don't like the way they wrote that.
Yeah.
So arc is just this.
Right.
Okay, that's the arc. So if you had to find any of these, you need to have 3 of the other pieces, right? You're always going to have the 360, but you may not have this. So I'll give a real example here. Let's pretend this is 90 degrees, okay? And let's pretend that we know the radius of this circle, and the radius is equal to 3, right? Can we find the arc?
Yes.
Yeah, we would just go 90 over 360. So I just set it up there, 2 pi r for the circumference. So it's 2 pi 3. Cross multiply this, but you could reduce 90 over 360 already. That's 1/4, right? So this is I didn't multiply it for a reason, because you can see already, this is 2 times pi times 3.
Yeah.
This 2 can break down the 4.
Where are you? You're still on the first equation.
Yeah, this can become a 2. So your final answer is pi, 3 pi over 2 equals the arc. Okay, but that's a classic arc question right there. And I purposely didn't multiply everything because I knew I was going to have to break it down. It would have been 6 pi over 4, but then you reduce it down to 3 pi over 2. So you would do the same thing if you're trying to find the sector. The sector is the actual slice of the circle that we're dealing with here. And I'm not going to do it, but I'll set it up.
Is that x over 360?
Yeah.
Thanks.
So this is x over 360 is proportional to the sector. That means the whole slice over the area. So it's not that different from the circumference and the arc. It's the key element that you'll need for either one of them is the radius. Because once you have the radius, you can find area or you can find circumference. Okay? Any questions on that? This is okay?
Can we do another problem like similar to that?
Let me see if we have one right here so I don't create one out of thin air. Let's do one more. I'll create one out of thin air. Let me erase this first.
Yeah.
So erase this. This time I'm going to change the degrees. Even though visually it doesn't look like it, I'm just going to make this 60 degrees. And I'm going to say the radius. I'm going to say this. I'll set it up the way they do it. They tell you if circumference of the circle is equal to, I'll make something up this, 81 pi, fine. So they gave you the circumference, and in the formula for sector, you're not using circumference.
Yeah.
So they gave you something different to give you a little twist. So what do you do with this information?
Do you have the arc?
You're finding, no, they didn't give you the arc. They want you to find the sector, but they gave you the circumference.
And the angle.
And the angle is given, yeah, 60. If this and x equals 60 degrees, yes. Who wants to do it? You want to try it, Nick? Try it, Nick. Okay.
Is it because we know that circumference equals pi r squared, which would be like
It's circumference pi r.
2 pi r squared?
That's what I'm talking about.
So, sorry, I'm tired, but it would be 2 pi r squared equals
Just 2 pi r. Not
2
even.
pi r equals 180 pi, right?
No. Equals 81 pi.
Oh my god.
So I'm going to write this out so everyone can see it.
Dude, what's my problem? Oh, you got this. I'm gonna wake up. No. 81 pi equals 2 pi r. Yes.
Okay, that's where we're at right now.
Anyone applies?
That's what I
do.
So how does this help us?
Oh, whoa.
Okay, Sharon?
Sure. You can find R, and with R, you can find the area.
That's right. So what do you do with this to find R?
You divide by 2 pi to get.
Yeah, you divide by 2 pi on both sides.
Oh,
So this is a little messy looking, but what's it going to be?
Decimal?
I would just keep it as 81 over 2 because these 2 pi's cancel out, so it's just 81 over 2. That's fine. It's all right. We're just going to continue. Now we have the radius. What can we do with that to find the sector here? Go ahead.
81 divided by 2 squared times
81
half.
halves
Yeah,
squared.
81 divided by 2 squared.
Right, so you're getting it as your area here, so you have 81 over 2 squared, 2 pi r squared. So this is your r. And that's, what can we do on the left side of the equation now? Go ahead.
60 divided by 360?
Yeah, 60 over 360. So we can find the sector. I mean, now it's just a cross multiply.
Now just a math.
I would reduce the 60 over 360 becomes, I would reduce that.
Oh,
112.
1 or 1/3? No, wait, what? No, that's.
It's not.
I'm sorry.
1/6.
1/6. It's 1/6.
I have to wake up.
Okay, now what?
You multiply 81.
Yes, you multiply that denominator on both sides to get rid of it.
That's so ugly.
I know. Let me erase this thing here.
Just saying. I want the numbers to be perfect.
Right here.
Yeah. Yeah. No.
So those two cancel out, right? And then you're down to this. I know it looks very unfriendly, but it's actually the reason why I haven't squared it yet. Does anybody know why I have not squared it yet?
Because that works.
It'll just exponentiate how ugly it is. Okay. What happens when you have this kind of a situation? When you have a number divided by a number, a fraction divided by a number.
Oh. Is it 81
So
over 2 times 6 over 1?
Yeah, so that's what it's going to be. 81
big book.
over 2 squared pi times 1/6. Now this is where you're like, oh, this is just a mess. But you guys kind of see, that would be the sector.
Wait, doesn't it flip?
It did. It did.
1/6 flip.
No, that is the flip because this is 6 and it becomes 1/6.
Oh, right.
It is the flip. So it's going to come out to be a messy number. I should have chosen friendlier numbers, but
that's the idea.
But that's the whole idea. That is the sector of it. That makes sense, right? I know you're looking at me. Some of you guys are looking at me like, I kind of get it. But the point of this is that once you have the radius, you can go either direction. Either find the circumference to find the arc, or use the radius to find the area, so you can find the sector. That's what that is. Okay. Point D at the bottom of this page here is talking about a tangent. And a tangent is simply a line that forms a 90-degree angle with the radius of a circle. So that flat line, that horizontal line, is the tangent.
Yeah.
And it's touching the circle at one point, making a 90-degree angle. Okay. Let's try number 11. I'm going to tell you, you guys have done something exactly like this already, except it wasn't with a circle. It's a square.
Spoiler.
Right. So everyone try number 11 real quick.
Individually?
Yeah.
Okay. Are they supposed to be clean numbers or messy?
This one's gonna be clean.
Oh,
I kind of made up that other one,
right.
off the top of my head.
Yeah.
but this will work out fine.
Yep. Come on. Square. 6. Oh, okay. Oh, wait.
Oh, no.
It's on the scale.
So this is the same thing that we did earlier.
Wait, just to be clear, the radius of the large is from the outside to that inner circle. Like, if you
Right,
draw
radius-
what the,
Radius of the large is this.
that's the,
Okay.
this figure is drawn to scale.
Okay, I'm going
Yeah.
to make them.
The one that has an 8 is the radius of the small. So remember our formula, area of the small plus the shaded equals area of the large.
Wait, where did we write that?
We did that with the squares. Same thing.
Dang it, I need to write that.
Area of the small plus area of the shaded equals area of the large. They gave us the shaded, remember the square they gave us, the shaded region was, I forgot the number on that one, but
And by area of the large, you mean all of the circles combined?
if you were to color in the big circle, it would
It's
be
not just that
area of
shaded.
the small plus the shaded equals the area of the large.
Oh, okay, I wasn't looking at it right.
Yeah. You get it already, Grace?
No.
Uh,
She doesn't mean like the radius.
We have the radius of the small is 8. Radius of the small is just this inner circle here. And the radius,
Shaded meaning is-
shaded, they gave it to us already. It's 80, this is 80 pi.
I think there we go, I found it. Wait, no, did I get it? I think I got it.
So I'm just labeling it. Radius of the small is 8.
Got it.
Okay, you got it? You finished
I
it?
think, yeah, last time
Does everyone want to hear how he did it? You don't want to hear it?
How did I do the magic
She
trick?
wants to finish it. Let's give it another minute here.
Yeah, man, that's.
Okay.
No?
Keep it down. Let her finish.
It's like a magic trick. Like, how do you do it? See, I feel like my problem is that, like, I could not do this until you told me it's using that equation.
Same thing.
So I need to just kind of identify
Yeah.
what you have to use, and then it's like,
Right. So what we're doing is I'm training your eyes so that way when you see something like this, where they're talking about a shaded and a small and a large, they might do it the opposite order. They might give you the total area and they might give you the shaded and they'll say, find the small, right? Or they might give you the area of the large and the area of the small. That would be too easy. Find the shaded and you'd subtract, right? So it's just a combination of these 3 things. They might do it with triangles. They might do it with other figures.
I got it wrong.
You want to talk about it? Okay, let's talk about it. I'm gonna let Shankaran explain because he sounds like he's got this. So tell us what you did here.
Okay, so we know the radius of the small circle is 8.
Right.
And because that equation, area of the small is one of the elements of it, you have to find the area of the circle. So that's pi r squared or pi 8 squared or 64 pi. Yes. Yeah, man.
This is right. This is pi r squared, so 64 pi.
And the shaded area is already given to you as 80 pi.
That's right.
Yes. So 64 pi plus 80 pi is 144 pi.
That's right. So it's 144 pi.
And now the area is pi r squared, or the formula for area of the full circle is pi r squared. So set that equal to 144 pi to get a radius of 12.
Right. Since we know this here is pi.
Whoa, I did something different. I got this answer.
Oh, that's 12 because 12 times 12 equals 144. That's all they're looking for. This is the radius of the large. The blue line that I drew here is what they're looking for.
Yes.
Right? Okay. Does that make sense to everyone who was kind of like, I still haven't fully digested? You guys are going to see this over and over again. I guarantee you'll see this on a practice test or something. You've probably seen it on PSAT. I've seen it on the PSAT too.
Before, yeah.
Yeah. Okay. This one's a little bit tricky on number 12. Let's do this together. I'm going to have Nick read 12 for us.
If each curved side of the figure above is formed from circumferences of two semicircles, each with a radius of 2, and each of the parallel sides has length 4, what is the area of the shaded figure?
Oh, man.
Oh, okay.
No.
Yes.
You want us to do it individually?
We'll
Try it.
walk through it together. I just want to see what people are thinking right now. I know it looks really weird, and most of you guys are like, we didn't deal with this in school. What the heck are you guys?
Oh, 2, 4, 6, 8.
The first thing you want to do with any figure is label it,
Yes.
right? So the first thing they tell us is this curved figure has radius. Each of the semicircles have a radius of 2. So I'm going to label that like this.
Would it help if we were to like complete the semicircle?
You could.
Yeah, man.
So radius works both ways, left and right. Does everyone see that? It also tells us that the parallel sides, this one and this one, are equal to 4. So this is a 4, and this is a 4. Let's keep labeling this, because Shankaran's like, is it okay if I complete these semicircles?
Wait, how did you get 2, 2, 2?
Because this is a radius here, this is a radius here.
Oh, I'm not even looking at
Do
this.
you guys see that? Everyone draw it out the way I'm doing it, because you'll see something pop out.
Nah.
Label the radius all the way across. Even though you guys are like, I know it's 2 already, label it all the way across. Let me see if this helps you guys by labeling. Yeah, Nick, you're.
Yeah, so I just, by seeing that, and like you have that line, like what if you just like lift that circle into the space?
Yeah, you could imagine you cut this off and you put it in there.
And then you have a rectangle.
That's right.
And then it's 2 times 4.
Yeah.
Imagine you had a pair of scissors, cut this semicircle, put it in here, cut this semicircle, put it in there. You got yourself a rectangle.
It's like magic.
What's the width here on the bottom?
8.
It's 8. So the area of the entire figure is 32.
Yeah, man.
It looked very confusing because some of you guys looked at the answers, you're like, oh my gosh, this looks terrible, right? But it's really not. And you looked at the figure probably thinking, what the heck do you call this thing, right? It's not even a square, rectangle, or anything. But when you make it more down to earth, like drawing the line all the way across, you realize, oh, I can do that. And it's actually just creating a rectangle, so it's 32. Okay, any questions? We're going to keep moving. I know there's a lot of math that we're doing, but I think this stuff is very important. That's why I haven't moved on to any new stuff. Let's talk a little bit about functions. And this is less about shapes and figures, but more about coordinate geometry. They're trying to relate functions because oftentimes you get these equations on them. And you don't necessarily need to graph them, but you have to be able to know why these equations exist. Jasmine, you want to read number 13 for us? 13, where it says
If
evaluating a function.
fx equals x squared plus 7x
Yeah, go for
equals fw equals 0, what is the possible value of
Right. Minus 7x. All right. So how many of you guys feel comfortable with this formula here? Or this? You do. What would you do next, Jeff? Go ahead. Keep going.
Can't plug it
I have a question.
in. You can go.
No, I want to let her
I
finish.
don't know.
You don't? Okay.
What is W in this? Like,
That's what I'm going to explain.
oh, okay.
Okay, so some of you guys are looking at it and you're like, what exactly are they doing with W? Where in the world did W come from, right? This is a classic situation where they kind of throw you off with this thing, which is f of x. When it's saying f of x, before we got into this advanced algebra, we just called it y, right? This is just like calling this y, right?
Mm-hmm.
When you call it f of x, it means this y value is the result of putting x into the equation. Does everyone agree with me? When I put an x value in here, let's make it 3. Okay, I'm just going to make up 3. If I put 3 in here, it would be 3 squared minus 7 times 3. 9 minus 21 is negative 12. Okay? If I did that, don't write this down. Okay? Don't write this down. I'm just saying if x was 3, y would equal negative 12, right? But instead of calling it y, these more advanced math people say it's the result of putting it's the result of putting x into a function. So that's why they call it function of x, because we put x in here and we got y. So as we got more advanced with math, instead of saying x and y, we started to say this. Everyone agree with me?
Yes.
You guys are cool with that, right? Let me erase this. This W it looks fishy, but what they're saying is they're just putting a different value. If x, I made up the number 3 for x. X was 3, right? Well, instead of calling it x, if x is equal to 3, we don't know what W is equal to. But when we put W into the equation, instead of getting y equals negative 12, we get y equals 0. Okay, so if we stretch this out, it's saying W squared minus 7W equals 0. That's the y value. Okay, y, this is your W value. Does everyone see that?
Yes.
That's a funny yes. He goes, yes.
Yes.
Yes. This is your no? This is your yes? I'm getting dizzy. Okay, but does everyone see? I gave you a weird example. I said, let's let x equal 3. We got negative 12 on it. What they didn't tell us when they wrote it was, they said f of w equals 0. What they mean is, put that w into the equation.
So
You're gonna get 0.
this is a function, so they showed us a function of x, but now they're showing a function of W.
That's right. That's right.
And y is what? Or, sorry.
Well, y is the result of putting w in there.
Gotcha.
When you put w in there, instead of getting negative 12, this time you got 0.
Uh-huh.
So we can find out what w values were. So factor out a w here. Does everyone agree you can factor that out?
Yeah.
Because this is w squared and this is w, right? So if that's the case, there's 2 scenarios that will produce a 0. That means if w equals 0, then y equals 0.
Yeah. Wait.
Okay. Or if w equals 7, then y equals 0.
Oh yeah. Oh. Oh.
Wait, what? I didn't get it.
Because if you put 7 in here, you'd have 7 minus 7 is 0. 0 times 7 equals 0. I'll write it out.
Oh, wait. I got
I'll write it out. This could mean either both of these scenarios produce a 0. So when you look at the answers now, which one can you choose? It has to be D. So when W equals 7, that's what we said right here. 7 times 7 minus 7, that equals 0. Did I lose you guys on this one?
No.
No? Yes? No? Maybe?
Maybe.
Okay, so I went 50% here. What I'm trying to say is this. We are used to putting X and Y together. It's a comfort zone because that's what we first learned, right? As we move forward in math, they started to call Y f of X, right? All they're doing is they're taking another step. Instead of calling it X, they're calling it W. And when you do W, whatever the value of W is, causes this equation in blue to equal 0. They just didn't write it that way. All they gave us originally was this. And that kind of left you hanging. What do you do with that? Where'd you get that from?
So they just told you what it was. They didn't actually write it.
Mm-hmm. Let me show you one other thing, because I just want to clear. I want people to have more of a confidence here. Now that we're kind of in this more advanced math, instead of thinking of this as plugging in W into the X equation, what this is really saying is this. So when you do equations, it means f of anything is anything squared minus 7 times anything. Okay? Because when we did it with X, that's what it looks like. We're not plugging W into X. This equation really is f of any variable is equal to any variable squared minus 7 times any variable. I don't know if that helps. Did it or not?
Yeah.
A little bit? Okay. I just don't want to lose you guys on this. Point B, right below this, what they're trying to reiterate, what they're trying to reinforce is what I just said here. The domain is the input. It's the numbers that you use to represent X, okay? In this case, I said, let's make X equal -3. When X equals -3, I think we got 12 or something. Or I put in 3 and then we got -12 on that. Domain is your input, your X values. Range is your output. It's your Y values. It's your f of X. Does everyone see that? Let's write that in there for point B, okay? Because I'm going to take it to a different type of question called symbol problems that are kind of tricky.
Yeah.
Okay? Stay with me, girls. You guys are looking like I'm drifting on this. Okay. Symbol problems are just like these things. And instead of just having f of X as your notation, they'll use symbols that don't mean anything in math. They might use something like hearts, diamonds. They might use the @ symbol. They might use a question mark or something like that. We know those don't mean anything in math, but what they do mean in the SAT is they're introducing a formula. They just want you to follow the steps. Okay? Grace, you want to read 14 for us?
Symbol B is defined as B minus A over 4. The expression A symbol B is defined as A plus B over 4. What is value of being symbol 5 times symbol B?
Okay, so I don't know if you guys have ever used this. These are I just drew stars because it's easier. I'll draw the asterisks just to look more accurate like them, but asterisks. So they use the asterisk symbol and they use the caret. Okay, so that's what those are. To do something like this, we got to follow the rules of PEMDAS. So the rules of PEMDAS means start inside the parentheses. So even though they introduced the caret formula to us first, we're going to do the asterisk formula first. So inside here, we're treating a 3 as your A value, and we're treating 5 as your B value. So that's what that is, right? So we're going to put them in the formula. They gave us the formula. It's nothing beyond what's on the paper right in front of us.
Oh, you could define 3 and 5 as A and B?
Yes, and then you're just putting it in their formula. They gave us the formula. It's right in front of us. So that's how I set this up. 3 plus 5 is 8 divided by 4. So the result of this is 2, right? Now that we have this 2, we're not done yet because we still have the caret formula. I don't even need the parentheses here, but do you guys see this here? This is now your A caret B. Does everyone see that?
Mm-hmm. Yeah.
So now we use the caret formula, which they gave us here. The caret is B minus A divided by 4.
Ah.
So since A was 2, B is 8, I put it in there, 6 over 4.
82.
A is 2, because look at the original formula. 3 asterisks, 5. We did all that calculation to get 2. That 2 is caret 8. Look at it's right there on the paper. So this is A and this is B, because the formula is called A caret B. So this is A, this is B. But when you do the math, you're saying B minus A. So that's 8 minus 2 divided by 4, 6 over 4, reduce it, 3 halves.
Do we have to reduce it for it to be a right answer?
You should. I would not leave it in unreduced numbers there. So the answer is 3 over 2. I know that felt a little bit weird, and you're like, whoa, we didn't do this stuff in algebra and algebra 2, but this is stuff they like to put on the test. And for those of you who did the homework, you probably ran into this and like, what is this? What the heck, right?
Yeah.
So that's what it is. Let's try to finish this up, and I'll go to a different topic besides math. But there's only 3 more questions here that I want to get into. Let's go to 15 first. Jasmine, you want to read 15 for us?
If GA equals A squared plus 10, what is the smallest possible value of GA?
Okay, Shankaran, you want to answer that?
I think it's 10. Or sorry, 1. Or I mean I plugged in the numbers.
He's thinking out loud, but I want to see if anybody else came up with anything.
I don't think it, like, there's not enough information given.
Not enough information.
Yeah.
There's like,
Just say it, Jasmine. What is it?
Well, never mind. Never mind.
So when you get this type of a question, this is similar to the math you guys had where you would try to find situations that were not possible in an equation. So you would look for asymptotes and stuff like that. That's whenever something could not, it reached a border or it reached a limit, right? This is similar to it because what you're trying to do here is make G of A as small as possible. So usually when you make something small, you either think of a negative or a 0. So plug in some values to A to make it as small as possible. What would you plug in there? Nick?
-1 and
If you put in -1, what happens to it?
becomes +1.
Right, so if you did that, this becomes 1 plus 10. Did that make it smaller?
No.
It actually made it bigger, right? So putting in -1 actually went, it gave us a backward result. It made it bigger. What else could we put in there?
0.
Let's put a 0 in there.
Wait, so what is it asking? What's the smallest possible value?
Of G of A.
Like,
Because when you have this, your G of A equals 11.
That's the smallest.
That's not the smallest one, because Shankar said, let's put 0 in there. When you put 0 in there, you got 10. That's,
well, yeah, it doesn't.
do you want to put a 3 in?
It doesn't like you.
It's 10. 10 is the smallest possible
10 is
value.
the small. Well, they don't have an answer for 3. You were saying the
How?
answer would be 3, or put a 3 in?
Because
If we put a 3 in here, Grace, 3 squared plus
0
10
squared plus 10 is
is 19.
If you were to plug in 1 squared plus 10 is 11. 10 is smaller than 11. If you were to plug in -1, that's also 10.
oh,
So putting in,
out of the
so
amount.
what the boys are saying right here is, if you put in positive or -1, no matter what, it's still going to turn out positive. And it's going to be added on 10. So I could go very negative. I could go -100, but -100 squared is 10,000 positive. That doesn't help us at all. Does everyone see that?
Yeah.
So our answer was the smallest possible value of G of A is 10. Because when you put a 0 into this equation, 0 squared is still 0. 0 plus 10 is 10. That's as small as it's ever going to get. Not going to get any smaller than that.
Wow.
Okay? I know some of you guys are like, this is a lot of tricks. But that's the way SAT math is. It takes getting used to. This is what I want to take a step back from just doing the next problem, and I just want to say this. At first you look at this and you're like, gosh, this is just a bunch of tricks. I don't see this stuff. What I want you guys to do is look over these problems again in your free time and kind of look at the wording of it. Because some students are like, no, just give me new stuff, give me new stuff. But I'm going to tell you, looking at new stuff is not necessarily going to help you as much as mastering what you have seen. Because when your eyes get used to this and you get used to the wording and you see repetitive tricks like small plus large and shaded, you start to see these things and you will anticipate what the test writers are trying to do. I've been teaching this stuff for 20 years, so my eyes are really, really well trained. And so I can predict what the trick is.
Wow.
So,
It's like magic.
but it's not magic. That's what I'm trying to say. It's not magic because when you see things over and over, I'll give you another example that's real to life. Most of you guys would be, how many of you guys have driver's licenses already? A couple of you do. Some of you don't, but you know what? It doesn't matter. You know why? If you had to find your way home from school, would you be able to do it without your GPS?
Yeah.
GPS. Oh,
Without your GPS.
Yeah.
You could do it. Why? Because you do it every single day. You've been back and forth from school to home, home to school. You don't even need a GPS, right? You could tell your friends how to drive you home or whoever, right? That's the same thing. It becomes muscle memory or brain muscle memory, where you're just like so used to doing this, it becomes routine. So I know some of the stuff you guys are looking at, and you're like, oh man, review it and turn it into your memory, okay? I want to do number 16 together. Let's have Nick read this one.
D of W equals square root of W squared plus 1 for all real values of W. Which of the following is not a possible value of D of W?
Whoa.
They're saying what is not possible as a result of this, meaning you can put anything in here for W. It says all real values of W. So any number you want, you can put in there. And looking at the answers, which one's impossible to get?
4.6.
Jasmine, you said something? I heard it, and it sounded pretty good.
yeah.
Yeah. Why are you saying 0?
Oh,
0 equals 0.
It can't, right? No matter what you put in there, you cannot make it equal to 0. You could put a negative number in there, but it's still going to be squared. It's still going to get squared, and it's still going to be added to 1. So no matter what you put, this is very similar to what we just did, the previous problem. Because since the variable w gets squared, it's going to be positive. So it's going to be adding on to 1. So it's impossible to get a 0. That's the answer. Yes.
So is it saying, which of the following is not a possible value of QW? It's like the whole thing after all the math.
Yeah, they're saying of this. 0 is not possible.
Okay.
And I'll show you how to do this mathematically without plugging numbers, because some people are like, I don't know what number to put in there. You'd have to square both sides. You'd have w squared plus 1 equals 0. And then you'd have w squared equals -1. Do you guys know why this is impossible?
You can have a
There you go. That's
Yeah,
it.
square root of it. Okay,
You get square root and square root.
that's I.
W is whatever. That's what's
So
going to
it's the I thing.
Yeah, it's the but they're not saying imaginary numbers. This is only real numbers. So, but you could have plugged it in normally and said, you know what, I can't get this to equal 0 no matter what I plug in here. Because if I put a negative, it still doesn't equal 0. If I put a positive, it doesn't. If I put a 0 in there, it still equals 1. So real numbers wise, it's not possible. Do you guys need to stretch? Do you guys want to do a quick break, bathroom break?
Sure.
Why don't we do that? Because I just don't want you guys to be exhausted. So why don't we do that for a minute?
Right, okay.